I stopped last time with t-test. Now I'm going to do another example with ANOVA. ANOVA is just one little step beyond t-test. So remember, t-test looked at the difference between means, and in the numerator was simply truly just a simple subtraction problem in the numerator. Well, now we used females versus males, women versus men in the last one. I'm going to change the example here. And now I'm going to do empathy in novice leaders versus leaders who are moderately experienced versus leaders who are very experienced. And we're going to say, what is their empathy level? Now, if we do a t-test, it's simply a subtraction problem. And in a t-test, we'd have to do novice to intermediate, we'd have to do 1t. We'd have to do novice to very, another t, and then we'd have to do moderate to very as a third t. And each time we do a statistical test, it has a level of error. Well, all of a sudden, this one's p less than 0.05, this one's p less than 0.05, and this one's p less than 0.05. And all of a sudden, with 3 tests, our p has gone up to 0.15. We actually have 85% confidence, 0.05, 0.05, 0.05, add them together, 0.15, if independent. There's a lot of different assumptions here, but for sake of this argument, well, we've done 3 tests, and with 3 tests, we've increased our level of error, and now we're only 85% sure across 3 tests, so we'd have to make some adjustment. So we don't want to do all these kinds of t-tests. Instead, what we want to do is a different statistical test that's more powerful in this situation. And what we want to do is ANOVA, analysis of variance. And remember, in the numerator, what we want to know, and I'm abbreviating, to error in the bottom. Well, we want to know, is there a difference among novice, moderate, and very experienced leaders in terms of their empathy? Is there, notice the term difference, not between, but among now, because among is when there's more than 2 comparisons. So what to know. And now to get into ANOVA, ANOVA is abbreviated with an F. Don't ask me why. If I made up all of the statistics in the world, I would abbreviate it with an A because it's ANOVA, but it's called the F statistic. Again, I wish I could explain where all these terms come from. But the F is the variability among the means. So it's a variability estimate in the top, and it's the variability due to error in the bottom. So instead of being the pooled standard deviation, it's variability. Now, if you remember, standard deviation and variability, abbreviated with an S squared, the square of the standard deviation is your variability coefficient. Variability is the square of standard deviation. Standard deviation is the square root of variability. They're just a simple calculation between them. And on a side note, t squared equals f, because t squared is based on standard deviation, f is based on variance. So they're very, very related statistics. And that's our f. Now, f, we have multiple things going on. We have multiple means. So our F statistic has 2 types of degrees of freedom, because we lose some degrees of freedom based on how many means we calculate, how many groups we have. So the first degree of freedom you see is how many groups we have, and we've lost 1 because we have 3 groups. So just like before, we have 3 groups minus 1, because we've calculated those means. We have 2 degrees of freedom. And then let's say we had means in the bottom, we'd have a second variability based on the sample size that we have. And I'm not even going to go there to get into the details of that. And so our F statistic is, I'm making numbers up now, is equal to 4.96 comma p less than 0.05. And this says, yes, those groups are statistically significant. There is a difference. And then we have an effect size measure, different in this one, eta squared. Now, the beauty of effect size measures is that they're completely, there's formulas to calculate. In the last couple of videos ago, I talked about the different ones. You can calculate a Cohen's d from an n of squared. You can calculate an r squared from a Cohen's d. There are translation formulas. So this is the simplest form of ANOVA. Now I'm going to get into the complicated stuff. There is the one-way ANOVA. And by the way, there's a whole chart about this on Blackboard. One-way ANOVA is one independent variables with at least two levels. Okay, now ANOVA can do everything t-test can. So we could do an ANOVA instead of a t-test, and it would be the same. Again, within square and square root, it would be exactly the same. ANOVA is usually used for 3 levels or more of one. Now, we have a factorial ANOVA, and that has 2 plus independent variables. Okay, now let me give you the example of 2 plus independent variables. Let's say we're going to put these two examples together. We have a 2 by 3 analysis. We have experience level, novice, moderate, experienced, and female versus male. That would be what's called a 2 by 3 factorial ANOVA. We have 2, and this is not an X, it's a time sign. So equals to 6 cells. 1, 2, 3, 4, 5, 6. Females who are novices, females who are moderates, females who are experienced, males who are novice, males who are moderate, males who are experienced. You get the point. That is a factorial ANOVA, 2 plus IVs. Now, we also have a MANOVA, and MANOVAs have 2 plus dependent variables. So we could have empathy and respect and trust, which would mean we have 3 dependent variables and we're measuring them separately. So we could have a 2 by 3 factorial. We can keep, it's like Garanimals. Anybody who remembers that kind of clothing from when I was a kid, you could mix and match. 2 by 3 factorial MANOVA, which means we have males versus females, novice, moderate, experienced, and we have empathy, respect, and trust. So 3 DVs, we're looking at them all the same. Now, we can also have ANOVA, which ANOVA has a covariate. And that means we know that there's a variable that makes a difference. So let's say we had done a leadership training program, and we could say that makes a difference. We've taught them how to have empathy, respect, and trust. And so we are going to remove that leadership training and see, regardless of leadership training, that's what's called a covariate. Remember this in regression, because a covariate is adding regression essentially into an ANOVA model. And then we can have, of course, MANCOVA, factorial MANCOVA, on and on. So this factorial MANCOVA would have more than one independent variable, more than one dependent variable, and a covariate. And so those all the different types of ANOVA models you'll see. They all boil down to the same thing. It gets very complicated. And once you get into those higher levels, I can't do it by hand, because you need to understand matrix algebra, which I do not. So they all boil down to what we know, what we want to know about in the numerator to err in the denominator, and it's what's going into this estimate and what's going into this estimate. And that is the F test, the variability among all those means in the numerator, the error variability in the denominator. Welcome to inferential statistics.